We're looking at some more linear relations, and in this example, we're comparing two birthday rental halls, what they're charging. So they love these comparison questions because it's something kind of realistic that you might encounter in real life. You have one company, it's called Birthday Blast, and they are charging $60 for the room rental and $40 per hour. So this yellow one here, that's the Birthday Blast, and it's charging this company's going 60 for the room rental and $40 per hour. So this $40 per hour, that is the rate. $40 per hour. This $60 for the room rental, that is like the deposit. So some people might say you have to put a deposit down, which is the initial fee. Which is your y-intercept, if you want to look at y-intercept. All right, so then we have this that we're going to put together into an equation. Okay, so what we have is for Birthday Plus, we're going to say the cost, we'll call it cost, maybe a big C, equals, we have $40 per hour and then $60 initial fee. So I would do 40 for each hour, 40 for each hour, plus 60. There you go. Party is charging only by the hour. So it's a $50 per hour. So that's just a rate. The rate is 50 per hour. So I'm going to say that this one, the charge for this one would just be 50 for each hour, and there's no initial fee or anything like that. All right. Now, let's look at those two equations. You have $40 per hour, that's the rate, and $60 initial fee. That could be a deposit, initial fee, the y-intercept, or the vertical intercept. And then here it's only 50 per hour. Okay. Second part of the question says graph both equations. So we're going to do this. We're going to drag this all the way up here so we can see. Now, we've got the cost, which is at dollars, and it's labeled for us down the side here. So 300, 200, 100. There's 5 squares, 1, 2, 3, 4, 5. So 100 divided by 5, that means that each square would be 20. So 20, like that. So then, it's a 1. Every square is 1, so we know it's 1, 2, 3, 4. We can label more if you want. And when we have here is graph both equations, yes. Okay. So what we have now is the graph. So for the Birthday Blast, it's $60 initial fee, $40 per hour. So that means you start the first dot at 60. So 2, 4, 6. So here, 60. So 60, that starts at 60. And then for 1 hour, it's going to cost $40 more. So 60 plus 40 gets to 100. And then another 20, 40 would bring us over here. Okay, we've got another $40, which would be 2 squares, right? Because 1 square is 20 here. So every hour, so every square, so 2, 3, 4, every square is 1 hour. So we're going up every hour to $40, which is 2 squares. So every hour is 40 like that. And I usually try to fill the graph because we do a comparison. When you're doing a comparison, we usually want to see where the two lines intersect. So I'm going to do a line here and connect this one here. So this one is birthday blast. So this one is birthday blast. There we go. Okay. Then we've got your cost is $50 an hour for party. So I'm going to do this one in green. Party is $50 an hour. No initial fee, so that'll start at 0. So here it starts at 0. And then at 1 hour it's $50. That's 2, 4, 6. So 50 is halfway in between the 40 and the 60, right? So 50 would be halfway in between the 40 and the 60. Then at $2 or 2 hours, that would cost us 100, so that goes up to 100. Then at 3, it would cost us 150, so it's 20, 40, and it's halfway in between, so this would be the 50, 150. Okay, so we're going up by 2.5 squares. So you go over 1 and up 2.5. So if you go over 1, you're going to go up 2.5 squares to 200. And then the next one, you're going to keep going until they intersect, and then you've gone as far as you can on this graph. So another hour would be 2, 4, and then half a square, and the next one would be over 1, and then up 2.5 squares, another $50 to get us to 300. Then 2.5 would be over here, and that would be it. Perfect. And we're going to graph this and put a nice little line here.